Hi, my name's Corey Ransom. I'm the Extension Weed Specialist at Utah State University. I'm excited to be part of this dryland field tour. I'm going to talk just a little bit about weed management and dryland cropping systems. When we look at a crop like safflower, what's really easy to notice is that most of the grasses have been controlled where the herbicide was applied, but the plants that seem to be more problematic are those broadleaf plants like kochia and prickly lettuce. And this is a spot where we had a wild oat trial last year, and you can see that the herbicide did a great job of taking care of the wild oats in this safflower crop. And that's one of the reasons safflower is such a great crop rotation. It gives you tools that are effective in managing things like wild oat or jointed goat grass that you don't have when you're in a wheat production year. So in contrast to the safflower field, in the field that has been planted to wheat, you can clearly see that the broadleaf plants like prickly lettuce and kochia have been very well controlled, and the only species that really is showing up in some abundance are the wild oats. And so again, it's much easier to control wild oats or jointed goat grass in a safflower crop than it is in a wheat crop. And vice versa, it's much easier to control grass weeds in safflower than it is to control some of the broadleaf weeds. Let's move back to safflower for a moment and look at some data from a trial evaluating weed control in dormant safflower. This work was done at the Blue Creek Research Farm in 2019 by Earl Creech and other members of the agronomic group. Some of the treatments they looked at included Spartan Charge, as well as Prowl, and then Sonland, which is kind of a standard. This year, Sonland didn't work at all. This chart shows pigweed control. And we see with pigweed, it took 3 to 4 ounces of Spartan or either rate of Prowl to provide a good control. And again, the Sonland was a complete failure in this year. Keep in mind the maximum rate of Spartan Charge in our area is probably 4 or 5 ounces. The next species was tumble mustard, and what we see with tumble mustard is that all of the treatments provided excellent control, except for maybe Prowl at the lowest rate, the 2-pint rate. The next species was prickly lettuce, and what we see with prickly lettuce is similar, that all of the Spartan rates above 2 ounces providing excellent control, and both rates of Prowl providing excellent control. For the next species, which is Russian thistle, what we see is Russian thistle is not controlled by Prowl, and so very poor control with Prowl, but even at the lowest rate of Spartan Charge, we're getting 100% control of Russian thistle. And then, as you would expect, those treatments providing higher levels of weed control provided a higher yield of safflower. And except for the rates of Spartan Charge, where we get above 4 ounces, between 4 and 8 ounces, it appears that we have some injury. So the weed control is excellent, but the injury offsets the yield. And so you have to be really careful with the rates of Spartan Charge, depending on your soil type and your organic matter. And at this point, this might suggest that the maximum rates, at least in these locations, is closer to 2 to 3 ounces of Spartan Charge. Switching back over to wheat production, we want to talk about research results and look at some plots of different herbicide treatments, including products that are a premixture of 2 active ingredients, single active ingredients alone, and then mixtures of different active ingredients. This first plot is an untreated, and you can see that the major weed problem here is prickly lettuce. And then actually there's a little bit of volunteer safflower in this plot. We move over to the next plot. We see our first herbicide treatment, and you can see that it's done a pretty good job with just a few prickly lettuce in there. Our next treatment, again, has really suppressed the prickly lettuce, but you can see there's quite a few surviving down in the canopy. And then this treatment, you can see really has not done a very good job. The prickly lettuce isn't as mature as it is in the untreated, but the control is not very effective. This fifth treatment, again, a pretty good job, but some prickly lettuce down in the canopy. And then the final treatment that we have in this trial, here again we see a pretty good job of weed control. And then for comparison, in the back here, you can see the prickly lettuce coming up in the untreated plot in the next rep. So again, quite a difference. It's interesting that you can almost see the difference in the size of the heads in the rows in that untreated plot where it's been under competition versus in this treatment where it's had the majority of the resources to continue to develop and grow. In general, what we have found through multiple years of research in small grains is that herbicides that contain 2 or more active ingredients, often different modes of action, in a premixture are more effective at controlling weeds in wheat than those with a single mode of action or a single herbicide. This is due to the fact that they have a broader spectrum of weeds controlled, where one herbicide mode of action is effective on certain weeds and the other herbicide in the mixture controls those weeds which maybe the first herbicide is weak on. This also provides a benefit of providing some resistance management or preventing the development of herbicide-resistant weed populations through having 2 modes of action. Also, we have noticed that MCPA, when mixed with other herbicides, can cause antagonism. So the effectiveness of those herbicides is reduced because of the MCPA being added to the tank mixture. This video that I will show demonstrates a plot, the previous plots that had a single herbicide mixed with MCPA, and you can see that the control of the prickly lettuce was severely reduced due to that combination. So not the type of control that you would be happy with. And then finally, it's really critical when putting together your weed management program that you choose the right herbicides to control the species that are present in your particular field, whether that is broadleaf and grass weeds or is a certain selection of species of weeds. Keep in mind that there are herbicides that can be used in wheat to control annual grasses. These include the graminicides, which have typically been used to control wild oat, including things like Achieve or Discover or Puma or Axial, as well as some of the ALS herbicides registered for use in wheat, including Everest and Osprey, which were widely utilized for annual brome control. And then, of course, herbicide-tolerant varieties like Clearfield wheat, which had the opportunity of controlling species like jointed goat grass in a wheat crop. I just want to point out that it's important to remember that all of those above options, if they're overused, can lead to annual grass populations that are resistant to these herbicides. And so that's where the utilization of a rotation with safflower allows the use of different modes of action that are not available for use in wheat directly. The last thing I want to mention is a new species of mustard, elongated mustard, which is definitely spreading here in Cache County in northern Utah. This plant seems to be doing very well in CRP as well as in dryland crop settings, and so I think it would be important for you to be on the lookout for this species. Elongated mustard is a simple perennial. It has the typical yellow flowers with 4 petals that we associate with the other mustards. It does flower later in the season than Dyer's Woad, which helps to distinguish it from Dyer's Woad. And because it is a simple perennial, it seems to be able to persist in these dryland environments very well. So again, I would hope that you would be on the lookout for this species. In conclusion, weed management is important in dryland crops to preserve yield. The use of crop rotation, including the utilization of safflower as a rotation crop, can assist in controlling difficult weeds, including some of the annual grasses. Herbicide selection is key to effective weed control by matching the herbicide to the weeds that are present on the field. And finally, new weeds are constantly showing up, requiring us to constantly adjust and change our management approaches. Thank you. I think I'm pretty close to time. If there's a quick question, I'd be happy to answer that. Otherwise,